So we have modeled whole numbers divided by fractions. We've done fractions divided by whole numbers. Now it's time to look at modeling fractions divided by fractions. There's more than one method, just like there usually is in math. So in this video, I'm going to show you a way to use two different boxes to do the division. The next video will be using one box, and then you can decide which one you like better. So if I look at these denominators, I've got a 3 and an 8. So that means that I want to make my box 3 by 8. And that can be 3 high by 8 wide, or it can be 8 high by 3 wide. It really doesn't matter. So I'm going to make this one 8 tall by 3 wide. Okay, and the fraction is a third. So I want a third of this box. So I'm going to color 1/3 of that box. Okay, now I need to do this divided by 1/8. So again, I have the 3 by 8. Just for difference, I'm going to make this one 3 high and 8 wide. And this one is 1/8, so I want to color one of the 8 columns. I could have done it the other way too. All right, so this is modeling 1/3 divided by 1/8. So we're really saying how many of these go into here. So how many yellow boxes do I have? 1, 2, 3, 4, 5, 6, 7, 8. I have 8 divided by 1, 2, 3. So I have 8 over 3. I could make that into a mixed number. 3 goes into 8 2 times, and I have 2 left over, so 2 2/3. Because if you think about it, these 3, I could do 3, 1, 2, 3. I could do another 3, and I'd have 2 left. So 2 2/3. And that's the way that you can use two boxes to model dividing fractions. So if we wanted to try it with the algorithm, we would have 1/3 divided by 1/8, and we do our keep, change, flip. So that means we keep the 1/3, we change to multiplying, and we flip that 1/8 to be 8 over 1. Top times top, bottom times bottom, and we get 8 over 3, the same thing that we got over here, which would also simplify to 2 2/3. So let's do one more like this. I want you to work along with me, so make sure you've got some paper or a whiteboard, something that you can work with. So for this problem, we have 4/5 divided by 2/3. And I want you to start with drawing your two boxes. Look at the denominators. We've got 5 and we've got 3. So that means that your boxes should be 5 by 3. Go ahead and draw them now. Okay, I draw mine as 5 tall by 3 wide. You could have also done 3 tall by 5 wide. It really doesn't matter. This one is 4/5, so it means 4 of these rows are going to be shaded in. There's my 1, 2, 3, 4 out of my 5 are colored in. Now I have 2/3, so that means that 2 of these columns are going to be colored in. 2 out of the 3 are colored in. So this is modeling 4/5 divided by 2/3. Now we need to figure out how many boxes are shaded in this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 divided by, here we have 2, 4, 6, 8, 10. 12 over 10. 12 divided by 10. Well, this is improper, so 10 can go into 12 one time, and I have 2 tenths left over. You could make that simpler. You could say 1 and 1/5. It's like we're saying, how many times can these 10 go into these 12? Well, 10 can go into this 12 once, and we would have 2 left over. Again, if we wanted to use our algorithm, keep, change, flip. You could simplify by cross products, or you can just multiply. I'm going to just multiply. 4 times 3 is 12. 2 times 5 is 10. I get the exact same answer that I got here, 1 and 1/5. If you wanted to do simplifying before, when you look at these, you can see that 2 goes into 2 one time, and 2 goes into 4 2 times. So 2 times 3 is 6, and 1 times 5 is 5. 5 goes into 6 once with 1/5 left over. So that's the way you can use 2 boxes to model dividing a fraction by a fraction.